Figure 3.7, Initializing Objects with Constructors. In this example, we're going to introduce another new feature of class definitions, a concept called a constructor. A constructor is a special member function of your class that is automatically called for you when you create an object of the class. And as you'll see later on when we proceed through the later lessons, it's possible for a class to have many different constructors that are used to initialize objects in different ways. Now first let's go ahead and take a look at the main program in this case. As we mentioned to you, once you put the course name data member into the gradebook class, it allows you to have separate gradebooks, each of which has its own separate course name associated with it. Now, the way we initialized the course name in the last program is we first created a gradebook object, and then after the fact, we went ahead and specified the course name by calling the set course name member function. But constructors are nice because they give you an opportunity to initialize the data in your class from the moment that you create the object of your class. And remember from lesson 1 that one problem with variables in C++ is that variables typically do not get initialized for you when you create them. Specifically, variables of primitive types do not get initialized for you. However, with object types or class types, you are given an opportunity to initialize all of your data right from the moment that you declare an object or create an object of that class, and the way you do that is via the so-called constructor. So let's take a look at the main function and see what we're doing in this example. At lines 49 and 50 in this example, we're creating two gradebook objects, one called gradebook 1 and one called gradebook 2. And for the first time, we're specifying parentheses after the name of the variable. And this is simply saying that we would like to initialize, in this case, gradebook 1 with the string CS101, Introduction to C++ Programming, and gradebook 2 with the string CS102, Data Structures in C++. And at lines 53 through 55, we then have some output where we're going to show you gradebook 1 created for course, and then we're going to tell the gradebook 1 object to give us its course name. And similarly, we're going to, on the next line, output gradebook 2 created for course, and we're going to tell gradebook 2 to give us its course name. And that way we should be able to prove to you that each of these gradebooks has its own course name associated with it, and specifically that they were initialized at the time we created the objects, because as you see here, we are not using the set course name member function in this example. So let's run the program first, and then we'll take a look at the updated gradebook class. So as you can see here, when we got to the end of the program and displayed our output, gradebook 1 created for course, CS101, Introduction to C++ Programming, and here you see that we said gradebook 1.getCourseName, which means that we went specifically to the first gradebook object to get the string associated with that object. And similarly, gradebook 2 created for course, CS102, Data Structures in C++. That again is being created or produced by the gradebook2.getCourseName member function call, and because we said specifically to get the course name of gradebook 2, it went back to the one that was declared at line 50, which you can clearly see has the string that was output in the second line here. So obviously we are able to initialize these gradebook objects at the time that they're created. The question is, how are we doing that? So let's scroll back up into our gradebook class and take a look at what we're doing here. So once again, we start the gradebook class, and we have our public section of the class, and we're carrying along with us, by the way, all of the features that we've introduced so far. So we still have our set course name member function that assigns name to course name. We still have our get course name member function that returns the course name as a string, and we still have our display message member function that's going to output the course name. Notice, by the way, that display message calls get course name back at line 29 to get the course name. This is actually a good programming practice. Within your class, even in the body of your class, you want to try to use your own set and get member functions when accessing your private data. And one of the reasons for that is it helps make your class more maintainable, more modifiable, and easier to debug as well. In the future, if you decide that you want to change the name of this variable, this line of code, as long as the name of the member function doesn't change, line 38 would not need to change. Or if you needed to change the data representation altogether to be something other than string, it's conceivable that this line of code still would not need to change. And this will become more apparent when we get to our later examples of class definitions. We'll show you a time class, for example, where we'll have hour, minute, and second variables that represent the hours, minutes, and seconds in a day. But one other way that you could represent the time is just the total number of seconds in the day. But the user of the class may still want to be able to get the hour, get the minute, or get the second. And if you write your code inside the class, almost like you're a client of your class's code, the way that main, for example, would interact with a class, that can help make your classes easier to maintain, modify, and debug. So again, we have the same member functions that we had in the previous version of class gradebook. We also have the same piece of private data. The thing that's new is lines 17 through 20, which is a definition of a gradebook constructor. Now, in C++, a constructor must have the same exact name as the class. So you can see gradebook with a capital G and a capital B, and the class name gradebook with a capital G and a capital B. That's the first requirement. The second requirement is that you are not allowed to specify a return type on a constructor. Constructors do not return values to you. You are not even allowed to say void for a constructor. The gradebook constructor in this case has one parameter, which is the string called name. You can have as many parameters as you want for a constructor. In fact, if you don't define a constructor for your class, which is the case in all of the previous versions of your class, the compiler will define a so-called default constructor for you, which is similar to a constructor that takes no arguments. And with the default constructor, depending on the classes that you're defining, the default constructor may not do anything at all. But as we proceed to later in this live lessons product and get into concepts like inheritance, we'll see that the default constructor actually does perform some tasks for us as well. So if you don't provide any constructors for your class, the compiler will provide a default constructor that takes no arguments, no parameters for you. If you define any constructors for your class, then the compiler will not define a default constructor for you. And the reason it does define default constructors is that it's actually required in C++ when you create an object of a class that the constructor for that object get called. So it has to be defined in order to be called. So here we have this gradebook constructor that receives a string, and all it's going to do is then call the setCourseName member function, passing that string into setCourseName, and setCourseName in turn is going to assign that value to the course name data member. And again, we just got finished saying that it's a good practice even within your class to use your own set and get member functions. We're doing that here on line 19, and that's going to become important later on when we add validation to the set course name member function, because then the gradebook class, constructor, rather than duplicating that validation, can simply rely on the fact that set course name already implements that validation and reuse that code by calling the member function directly.